So now we are on question 4. Question 4, right? It says study the velocity, versus time graph, below for the motion of a car traveling east, right? Traveling east, right? So here we have 45, 40, 35, 30, 25, 20, 15, 10, 5, then 0. So this is the velocity, right? Then here we have 10, 20, 30, 40, 50, 60, 70, and 80. So it starts here at point A. So at point A, it goes to, from point A, it goes to somewhere on 20. Yes, on 20. Then it goes to 40. Goes to 40. 40 and 30. 40 and 30, somewhere there. Yes, so it goes like that. Then from there it becomes constant, then to 60, 40, 50. So this is 50, this is 60. Then it goes to 60. So this is A. This is A. Okay, let me do this. A. This is A. Or let's say A to B. A to B. So this is point B. Then from B to C. It's like this. Yes. Then from B to C. And that's D. And that's E. And this is F. Like that. So this is the velocity diagram. Alright. So these are just to show that it's passing through 30, 20, 40, like that. So we have time on the horizontal axis, and on the vertical axis we have in velocity, right? Meters per second. Alright, then 4.1, question 4.1 says define acceleration. Then 4.2, it says use the graph to describe the motion. Use the graph to describe the motion of the car. In the following sections, right? So 4.21 AB, we want to describe the velocity AB. That's 4.21. Then 4.22 BC, that is BC, we want to describe the velocity BC, right? Then 4.23 DE, again DE, we want to explain what is happening there. Then 4.3, it says calculate the acceleration calculate the acceleration. Calculate the acceleration between A and B. Calculate the acceleration between point A and point B. Then 4.4, it says without using equation of motion, without using the equation of motion, without using the equation of motion, calculate the distance. Calculate the distance covered by car or by the car from A to F. So these are the questions. Let's quickly write to the solution. Alright. So we want to go to the solution. For question 4 or question number 4. So we want to define the term acceleration. So we know that acceleration is the rate of change of velocity with respect to time. So we are saying 4.1. Acceleration is the rate of change of velocity. It is the rate of change of velocity with respect to time. So we're saying acceleration is the rate of change of velocity with respect to the time. Then 4.2, it says, now we're on question 4.2, and on question 4.2 we are asked to determine, use the graph to describe the motion of the car in the following sections A to B. So at A to B, or at AB, 4.21, A to B, we can say the velocity is increasing, right? Velocity increasing, right? Velocity increasing, and acceleration, velocity is increasing and acceleration is constant and positive, right? That's A to B. Then 4.22, then B to C, we say the velocity is constant. We can say that the velocity is constant and acceleration is 0, and acceleration, the velocity is constant and acceleration is 0, right? Then D to E, that's 4.23. D to E, from the diagram that we drew earlier, the velocity is decreasing. So we can say velocity is decreasing. Velocity is decreasing. And acceleration is negative and constant. So that means we have described A to B, velocity is increasing and acceleration is constant and positive. Then B to C, velocity is constant and acceleration is 0. Then D to E, velocity is decreasing and acceleration is negative and constant. That's what we were given from the diagram. Then question 4.3. Now the question 4.3, it says determine the acceleration of the car between point A and point B. Acceleration of the car, right? So how do we find the acceleration of the car? So for us to find the acceleration, So we're saying 4.3. 4.3, we're saying acceleration of the car between A and B, acceleration of the car between point A and B. So we're going to find the initial velocity. So the initial velocity at A, because A was the starting point, or A is the starting point. So the initial velocity at A was 0. So we're going to say 0. So we're going to say 0 meters per second was the initial velocity, right? And this was at 20 seconds, all right? So for us to find the velocity, we're going to use the formula A equals to the acceleration. A equals to V minus F minus V, or let's say like this, right, to I, which is the initial velocity, divided by, right, T for time, T to the final velocity minus time to the initial velocity. So we are going to get A equals to 10 meters per second minus 0 meters per second divided by, right, 20 seconds the time minus the final velocity, which is 0 seconds, right? So what are we going to get? So this is the time. Let's use that as the time. So we're going to say A, we are given 20 seconds is equal to 0.5 meters per second squared. So I'm saying at 20 seconds, this is the answer, 0.5 meters per second squared, right? Then we are asked the last part of the question, without using the equation of motion, calculate the distance covered by the car from A to. So that means we are supposed to find the area of that whole graph. The area of that whole graph. That means we are going to divide the graph into sections, and we calculate the area of each section, and we add all the sections, right? So let's divide the graph into the sections. So the sections are going to be AB. So we're going to divide AB, right, BC, then CD, we don't need CD, then DE and EF. Alright, so we're going to divide our graph into those sections. So AB is a triangle, right? AB is a triangle, and we have to find the area of the triangle. BC is a rectangle, and we know how to find the area of a rectangle, right? Then DE, triangle again, and we know how to find the area of a triangle. EF, a rectangle as well, and we know how to find the area of a rectangle. So we have to calculate area under the graph, will be the total distance covered by the car from point A to point E. So let's start by area of AB. So I'm going to say area of AB, which is a triangle. So let's say area of triangle AB will give us half base times height. So we're going to say half times, we are having 20 seconds times 10 meters per second, which is the velocity, which will give us as 100. So we're going to get 100, right? So let's just use 100. Then area of, now we are on a rectangle, BC equals to length W, or length times breadth, right? Whatever that we want. So that means we're going to say, for us to find, we're going to say 40 seconds minus 20 seconds, right, times 10 meters per second That means you're going to get 200 meters like that. Then area of DE equals to half base times height, again because it's a triangle. So area of triangle DE is half base times height, which will give us half of 60 seconds minus 40 seconds times 30 meters per second, the velocity. So we're going to get 300 meters per second, right? Then area of EF, then area of rect EF, right? So just length times W, or W times B, B representing the breadth, which is also the width. So we're going to say now 70 minus 60 multiplying 0 meters per second, which will give us 10 seconds times 0 meters per second, which will give us 0 meters. So now we are going to say now the total distance traveled by the car from point A to point E to point EF, I mean, is equals to area AB plus area BC plus area DE plus area EF, right? So now we are substituting the area, so we're going to say 100 meters plus 200 meters plus 300 meters plus 0 meters. That means we're going to get 600 meters. That is the total distance traveled by the car from point A to point F.